This question tells us that ethyl acetate can be produced by reacting ethanol and acetic acid in a battery reactor. The reaction is simplified by the symbols A plus B forms R plus S and vice versa, with a forward rate constant of K sub F and a reverse rate constant of K sub R. So the first part, part A, tells us to write the equations for forward and reverse reactions based on reactant A. So for forward reaction, we can actually write it as a forward reaction. We can write it as Ra minus, which is the rate of disappearance of A. It's equivalent to the forward rate constant Kf multiplied by the concentration of A. For our reverse reaction, on the other hand, it is written as Ra plus, which is the rate of formation of A, is equals to Kr, which is the reverse rate constant, multiplied by the concentration of R. Part B asks us to use material balance to derive the design equation for the above reversible reaction based on reactant A. And material balance based on reactant A is equivalent to the amount input into the battery reactor plus the amount generated is equivalent to the output plus the amount reacted plus plus the amount accumulated. Here. And since this is a batch reactor, the amount input and the input and the output will both be equivalent to 0. The amount generated will be Ra plus, the formation of A, multiplied by the volume of the battery reactor itself. The amount reacted will be Ra minus, multiplied by the volume of the reactor. And the amount accumulated will be the differential of concentration of A multiplied by the volume over dt. And since we have V on the left and V on the right, we can cancel them out. And since the volume of the reacting mixture in this case is a constant, since we're using a battery reactor, this can be cancelled off as well. So using the rate equations given above, which is these two equations that we wrote in part A, we can substitute these rate equation into this lovely thing here, and it will therefore be written into this equals to this minus this, which is actually negative dCA over dt, equivalent to Ra minus plus Ra plus, which is also written by substituting these two equations as Kf Ca plus KrCr. And there we have it. And if you want to actually integrate this equation, if you want to get even though the question asks integration, it tells us that integration is not required. If you want to actually know, you will actually get, if you integrate this equation, you will actually get ln Ca minus CAE, which is the concentration of A at equilibrium, over CAO, which is the original concentration of A, minus CAE. It's equivalent to negative rate constant forward plus rate constant reverse multiplied by T.